Welcome to the presentation for Group 1, Lab 1, ECEN 160. We are reviewing the alarm and fan circuit lab today and implementing it via the simulation tool Logisim. Our presenters are Joshua Higgins, Christopher Virgin, and Tubi Yang. We started by analyzing the truth table that was provided to us. Once we had the midterm expansion equation for the alarm of C0 V T0 or C0 V T, we started to simplify it. For the alarm, we use the simplification theorem, number 10. We can remove the chord as it cancels out to just V T0. Again, using the simplification theorem for the fan, C0 V naught T or CV naught T or CVT, we can reduce it down to CT or TV naught. Using the combinational analysis tool in Logisim, we can find that our derived truth table matches the truth table that was presented to us, thus validating our design is accurate to the specification. Understandably, this truth table is simple and can easily be tested using the poke tool. In cases where the outputs are many, this could definitely save time. The truth tables gave us the following gates to work with: 3 AND gates, 1 OR gate, and 2 NOT gates. We can easily read this straight from the equation, when it reads, on the alarm, V and T naught. The AND gate is inherently said as you say it out loud. For the fan, C and T, or T and V naught. Hence, 2 NOT gates, 3 AND gates, and an OR gate. Here we can plainly see the use of AND, OR, and NOT applied. The inputs for our fan and alarm circuit were already given to us as chord, low voltage, and temperature, and the outputs being alarm and fan. Following the AND gates, OR gates, and NOT gates, we inputted those into Logisim in this manner.
Now here, we're going to test our digital circuit design. And for the sake of time, we'll test by running just a few simulations. As you can see from the truth table, the fan should only have an output of 1 when the inputs for chord and temperature are 1 and low voltage is 0. So let's use Logisim to simulate this. So chord is 1, temperature is 1, and low voltage is 0. And there you have it. Fan has an output of 1. Now the alarm should only have an output of 1 when the inputs for chord is 0 and low voltage and temperature are 1. So let's make those changes. And there you go. Alarm has an output of 1. And just to do one more check, both the fan and alarm should both have an output of 0 when the inputs for chord is 1 and low voltage and temperature are 0. So I'm just going to reverse these inputs. And there it is. Alarm and fan both have outputs of 0. So after testing all the different input scenarios on our digital circuit, we concluded that the outputs of our digital circuit match the expected outputs of the truth table. Now the lab wasn't perfect. We did face a few challenges, particularly in simplifying the equation. When we simplified the equations, it was somewhat difficult to see patterns at times and when to use certain theorems. Along with simplifying the equations, we also learned that there could be multiple simplified answers to an equation. So even though you and another person have different simplified answers, you both could be right. And one thing to make note is to remember that the plus sign means OR. Some of us have worked with coding, and typically a plus sign means concatenation in some programming languages. And so it's easy to think that the plus sign is an AND, but really it means OR in Boolean algebra.
Now let's take a look at getting our expressions and putting them into Logisim. Now fan is a little more complicated, but it's not as tricky as it may seem. We have chord, temperature, or temperature, not voltage. I started with the C and T because it was very straightforward. You had chord and temperature going straight into an AND gate. None of them were knotted. And then you also have T, not V. Temperature went into another AND gate, and we had not voltage. So voltage branches off here to an inverter that goes into this AND gate. And now both of these AND gates, as we see here, lead to an OR gate, and that OR gate leads to fan. So that's how we implement into Logisim.